Good day, everyone. I am Ian Radico Marino, and I am here to discuss to you about access list. First, let's start with what is an access list. Access lists are basically filters, something that stops a packet from going in or out of a particular network. The formal definition for this is access lists are filters that enable you to control which routing updates or packets are permitted or denied in or out of a network. In or out meaning ingoing or outgoing packets will still pass through this particular access list. For example, you can actually deny uh, inbound inbound packets such as I compare, for example, to going inside your network, or outgoing packets such as an email to go out of the network. They are specifically used by network administrators to filter traffic and to provide extra security for their networks. This can be applied on all routers, especially on Cisco. Let's move forward. Why use access lists? Access lists provide a powerful way to control traffic into and out of your network. As I said earlier, it can actually filter out ingoing or outgoing types of packets. This control can be as simple as permitting or denying network hosts or addresses. You can also configure ACLs for all routed network protocols. The most important reason to configure ACL is to provide overall a security for your network. However, ACLs can also be configured to control network traffic based on TCP port being used. The great example for this is would be torrenting. Torrents actually use a specific type of port in order to transfer data. So, for example, if in your network you don't want to have torrenting torrenting enabled, you could actually block this particular port, and that would actually stop all types of torrenting inside the particular network with just blocking of one port. You don't even have to block any other. Next, basically this is how an ACL works. From the top, you can see here, this router, since ACLs are actually settings that you put on routers, this particular router allow email but deny telnet. So they allow email ingoing and outgoing, but deny telnet, usually an outgoing packet. Um, this particular router, R1, denies video to S1, which is this switch, deny access to switch 2 from switch 1. This particular router, however, denies access to the web and TFTP server. So, how this works is that basically anyone connected into this router would actually have no email or telnet. So that means VLAN 10, VLAN 20, and VLAN 30 actually does not have any access to email and telnet. I mean, allow email. Let me correct that. Um, However, on R3, its settings is to deny access to web and TFTP server. So we have VLAN and VLAN 20 and VLAN 30 here. However, even though that they are connected with the web or FTP server on the same router, they could not access it due to the fact that the ACL on router 3 denies it. However, since router 1 is connected to the FTP server via the router 2 and router 3, you can actually access the TFTP server using VLAN 10. For router 1, which has an ACL of deny video to S1, SW1, switch 1, and 2, deny video to switch 1 and deny access to switch 2 from switch 1. So what happened here is that switch 1 cannot access switch 2. So VLAN 10 cannot access VLAN 20. However, it could actually have an access to switch 1. Okay, let's proceed. How ACL works. A router acts as a packet filter when it forwards or denies packets according to filtering rules. As a layer 3 device, a packet filtering router uses rules to determine whether to permit or deny traffic based on the source or destination port. Oh wait, it's based on the source and destination IP addresses, source port or destination port, and the protocol of the packet. As you can remember, there are various types of data inside a packet. So from here, ACL can actually figure out whether to let this particular packet pass or not. Let's move on forward. To simplify how ACL or a router uses a packet filtering, imagine a guard stationed at the locked door. The guard's instruction is to allow only people whose names appear on a guest list. This is actually a guest list, not a quest list. To pass through the door. The guard is filtering based on the condition of having their names on the authorized list. When a packet arrives at the router extracts certain information from the packet header and makes decision according to the filter rules as to whether the packet can pass through or be dropped. Packet filtering process works at the network layer of the Open Systems Interconnection OSI model in the internet layer of TCP/IP. Uses of ACL. Basically, you use ACL to one, limit network traffic to increase network performance. So, for example, in a school where you want people to not access Facebook, you can actually use an ACL so that nobody inside this particular network would be able to use Facebook and and will not then eat the bandwidth of the particular network. ACLs provide traffic flow control by restricting the delivery of routing updates. So we all know that routers actually constantly update whenever in certain moments of time. With the use of ACL, we can actually limit this so that we would not congest the particular system. It can be used as an additional security, and that it controls which type of traffic are forwarded or blocked by the router, and the ability to control which areas a client could access. This particular example would be very good, for example, in a web development type of server. For example, you don't want people who are actually just doing design uh, to access the database because, to be honest, they don't really need to use that. So you could actually only let them access the part of the server that holds all the CSS and HTML files. You don't want them to access the servers because that would be horrible. They could actually edit it and maybe fuck things up. Anyway, moving forward, there are certain types of ACL. One is the standard access list. Standard access lists create filters based on source addresses and are used for server-based filtering. Address-based access lists distinguish routes on a network you want to control by using network addresses number or the IP. Address-based access list consists of a list of addresses or address ranges and a statement as to whether to access to or from that address is permitted or denied. For example, again, if you want to block Facebook, there's an actual specific IP address that you could actually put so that you will be able to block Facebook. For example, we could actually run a particular uh, thing here, ping facebook.com. From here, we can actually see the IP address of Facebook. So, for example, in the access control list, you put this particular IP address and then say that do not allow any connections from this particular IP address. It will be instantly blocked. Okay, moving forward, there is also an extended access list. Extended access lists create filters based on source address, destination addresses, protocol, port number, and other features that are used for packet-based filtering for packets that traverse the networks. This is actually for packets itself. For example, there's a packet for ICMP or iCompare. You could actually block this uh, and totally remove that. Next would be masks. Masks are used with IP address on in IP ACLs to specify what should be permitted or denied. Masks in order to configure IP addresses on the interfaces starts with 255 and have the large values on the left side. For example, IP address 172.16.2.14 with a 255.255.255.0 mask. Masks are for IP ACLs are the reverse. For example, mask 0.0.0.255. This is sometimes called an inverse mask or a wildcard mask. When the values of the mask is broken down into binary and zero ones, this will determine which addresses or bits are to be blocked or allowed to pass. Okay, and that's it. And thank you for listening.